Hello everyone, welcome to Geeks for Geeks. I'm Ayush Shukla here with the post-contest analysis of Biwizard contest, and today I will be discussing the coding solutions, and I will be discussing the MCQs too. So be with me, and I will be discussing all the coding solutions. So can you confirm whether I'm audible or not? Okay, so let me begin with the test analysis, and here I will be discussing all the three solutions, that is coding solutions, and will be moving forward with uh, the MCQs part. So the very first question of the contest is beautiful sum problem. In this problem we are given a scenario that is Ravi is fond of mathematics, and once he heard the concept of beautiful sum. So here the concept of beautiful sum is that is we have to find the absolute difference between the sum of all the values at even indexes and the sum of all values at odd indexes, and we have to find the difference of both, and here we have to return the absolute differences. So let me explain from the example. Suppose we are given the example as 3 uh, 2 3 and 5. Okay, suppose this is the given example. So here the values, this is at index 0, this is at index, let me write the indexes 0 1 2 and 3. So clearly this is at in even index, and this is at even indexes. So sum of even index, sum even will be equals to 3 plus 3, that is equals to 6, and sum of even odd indexes, sum of odd will be equals to 5 plus 2 7. So clearly the absolute difference between the even sum and the odd sum here in this case will be equals to 7 minus 6, that is equals to 1. That's what we have to return here. So I have applied the same concept here, that is we will be running a loop from I equals to 0 to n, and here we'll be checking if I modulus 2, if I modulus 2 double equals to 0. In that case it means it will be equals to even indexes. So here we'll be adding the sum to the even index, sum plus equals to array of I, and here let's suppose it is sum 1. Okay, and if this is not the case, then we'll be adding it to the sum2 variable, else we'll be adding to sum2, that will be holding the odd indexes variable. So here array of I, if it is even then we'll be adding to sum 1, and if it is odd then we'll be adding to the sum 2. And once the loop is done, that is 0 to n, we'll be return the absolute difference between both. So absolute of sum 1 minus sum 2. So that's what we have to return here. So let me show you the code and explain it from there also. So here we are given the function that is int beautiful sum, and we are given the input as array and the value n, that is the size of the array. And here we have initialized a even sum variable and the odd sum variable, both equals to 0 initially. Then we have run the loop from I equals to 0 till I less than n, and I plus plus, that is from 0 to n, and then we have checked the condition, that is if I modulus 2 means if it is at even index, then we'll be adding the sum to even sum, and if it is at odd index, then we'll be adding the sum to the odd sum. And once we have done the iteration, we'll be just returning the absolute difference between the even sum minus odd sum. So let me compile this code. Yeah, for compilation it is okay, so let's submit it. Yeah, for submission also it is okay. So I think we are done with this question. So if you have any doubt, you can ask in the comment section. I will be actively checking those comments, so you can ask. Okay, moving to the next question here. We have the second question, that is coding question. It is of medium level, and here we have been given the question as reach the end problem. So here the given scenario is that you are in a geeker town, and here we have n buildings numbered from 1 to n, and we have been given the height of each building. So here we are given the scenario that is, if we are moving from one building to the other building, that is uh, so if you are at index x, suppose, and you are moving going to index x plus 1, so in that case we will be spending ax minus ax plus 1, that is absolute difference of both the adjacent buildings. We are spending that much energy. And if we are moving from x to, that is, one between, we are leaving the one building in between, in that case we have to spend two times the energy of the differences. So that's what. And we have to find that we have to move from starting building to the last building in spending the minimum amount of energy. So suppose we are given the scenario as, let's consider the example here. Here we are given the buildings as 1, 8, 2, 3 and 4. So here we are given the correct way. So let me find the correct way here. So correct way is, we'll be moving from first index to the third index, then we'll be moving to the fourth index, and then we'll be moving to the fifth index. So let's understand how much energy we have to spend here. So from moving from our 1 to that is third index, we have to spend two times the difference. So 2 into, and the difference is 1, so 2 plus 1. Okay, and next, here we have to spend 2 to 3, so here the clearly difference is 1, and since we are moving to the just adjacent, we have to spend only one time of that difference. And we are moving from 3 to 4, here also the difference is 1, and we are moving to the just adjacent, so we have to add only one times. So here the clearly the sum will be equals to 4 in this case. That's what the minimum energy we have to spend here. If we have chosen the different, suppose different path, let's consider the different paths. Suppose we have moved from 1 to 4, 8. So clearly at this point only, we have to spend the energy that is equals to 7. That is the difference between. So clearly 7 is already greater than 4. So there's no need to check for further, because here only the difference between first two buildings is 7, and here we are spending the more energy. So that's what we have to check here, that we should spend the minimum amount of energy. So for this question, we can have the both the approaches. We can check both the approaches here. That is, we'll be moving to the adjacent building and the next to next building also, and whichever will be giving the minimum, in that case we'll be returning that. So we have to find both the possibilities here. So let me show you the code and explain from there, so that you can better understand. So here we are given the function as int solve function, and we are given the heights of the buildings, that is vector int and h, and then we'll be having the size of the denoted by n. And here I have created the dp array. Dp array will be storing the difference between, and whichever will be giving the minimum will be returning that. So here we have, suppose we have the array that will be storing the differences of all the possibilities in the vector form. So here we have, for the first position we have the difference between the h1 and h0, so that we can start. And from the I equals to 2 will be dealing with the from I equals to 2 till I less than n will be dealing with this array. That is, if we are considering the next building, that is dp of I minus 1, so in that case we'll be adding the absolute difference between hi minus means the two adjacent buildings. And if we are considering the next to the next building, means leaving one building in between, in that case we have to add the difference and into two times. So that's what we have taken here, and we have taken the minimum of both. Whichever will be giving the minimum, we have considered that. So at the end we'll be having the whatever will be the result at the dp of the last position, that is dp of n minus 1, that will be our result. So that's what we are returning here. because it will be holding the minimum energy that will be required. So let me compile this code. Yeah, for compilation it is okay. So let's submit it. Yeah, for submission also it is okay. So I think we are done with this question also. And if you have any doubt, you can ask in the comment section. Here we are applying the DP concept here, that will be finding the both the possibilities, and whichever will be giving the minimum will be resulting that in our answer. So that's what we have applied. If we are considering the next building, then we'll be adding the absolute difference of the two buildings here, and we'll be moving. If we are considering the means there is a one building in between, we are moving to the next building. In that case, we will be adding the two times the difference of the energies of both the buildings, that is and the difference of both the heights. So that's what here we have done. Now moving to the next question, and that is the last question of the contest here in coding. So here we are given the scenario as let me write the scenario here. Okay, so here we are given the scenario as we are given the n fighters numbered from 1 to n, and they are standing in a line from 1 to n, and we have been given the power of each fighter, that is represented by the array of I. And if the fighter is standing at the ith index, so his power will be ai. So here we are given the scenario as that here means here a fighter can kill his opponent that if his opponent is adjacent to him and is not stronger than him. Means suppose we are considering these two fighters, okay, and here we'll be considering this if the fighter number is at index 3, that is 4, and here it can kill the fighter at index 2 and index 4 because they both are not stronger than him, because here the power of fighter number 3 is greater than the power of fighter of number 2 and power of fighter number 4. So here will it he will be uh, defeating the both the fighters, that is 3 and 2. So he can kill the power and kill the fighters. So that will be the case. That's what we have been given here. After his opponent gets killed, here we are given one more scenario, so that if he kills this these fighters, suppose 4 kills this 2, so now this 2 will be becoming the next fighter adjacent to 4. So this is the given scenario, that is after his opponent get killed, the adjacent opponent of fighter will become the adjacent winner of the winner fighter. And if the ith kills the fighter I plus 1, then the fighter I plus 2 will become adjacent to I plus 1. So here we are given the same scenario, that is if one is adjacent, if adjacent fighter is killed, in that case the next fighter adjacent to that will be now the new adjacent to the winner fighter. So that's what we have been given here, that is new adjacent new will be winner to that. So here we are given the array has array, and we have to find how many if the power of suppose the adjacent fighters is greater than the given fighter, so in that case he can't kill any fighter, so he can't defeat. So in that case we'll be returning 0 in that case. And if the power is greater than the adjacent, in that case we'll be returning the number of counts that he can kill. So here we are given the array, and we have to, for each fighter we have to find how many fighters he can kill adjacent to that. So here we are given this question example as 5 3 4 5 3 4 2 and 2. So these are the power of the 5 fighters that we are given. So here we'll be considering the same, and okay, So moving to the question part, and here we are solving the question, that is maximum kill problem. So here we have been given the input as the power of 5 fighters, and we have to find uh, the array, that is output, that we have to return how many fighters each fighter can kill, that is adjacent to them. So here for this question we can have the approach, that is here we will be using two stacks for implementing this question, and firstly I will show you the logic, and then I will be implementing that, and I have implemented that, so I will be showing you the code. So here we will be having the two stacks for the uh, suffix and the prefix. Suppose we'll be finding the fighter with each end. Suppose we are moving from here, then we'll be finding for each we'll be having the left side, and whichever will be the at the top of the stack, we'll be checking whether the power of that is greater than this or not. If it is greater, then that we'll be adding the count, and if it is not, then we'll be decrementing the count. We'll be not doing something. So this is the kind of logic that we will be implementing, and here we will be finding from the both the ends how the fighter are proceeding, and how many fighters they can kill. So for this question, let's suppose we have two arrays, that is prefix array and suffix array. So we'll be initializing the prefix array with the -1 and tell the size of the queue, size of the array. So here the prefix array in this case will be initially -1 equals to, all will be -1 initially, okay, and the suffix array will be the equals to the size of the array. So suffix array will be equals to, the size will be equals to 5 here. So suffix array will be 5 5. This is what we have initially, okay. Now moving to the question part here. uh, Now let me show you the code. Here you can understand better what I am saying. So here we have initialized the two stacks, and we have initialized the prefix array and the suffix array, okay. Then we'll be checking the condition, and then we'll be running a loop from starting, that is I equals 0 till I less than n I plus plus, and here we'll be checking while the stack is not empty. So here stack is empty, and here also stack is empty. So here we'll be pushing the current I index, so 0 will be pushed here, okay, 0. And now moving to the next iteration, here the stack is not empty, and we'll be checking if a of st.top. So st.top will be equals to 0, and a of 0 will be equals to 5. So here we'll be checking a of 0 will be less than equals to a of I is here 3. Note this is not the case, so we'll be not doing anything, and if st.not empty, we'll be pushing pi equals to st.top. So st.top here will be equals to 0, because the stack is having only the 0 value here, so 0. And now stack will be pushing 1 to the stack. Now 1 is pushed, because here we will be having the st.push. Again moving to the next iteration, here we have the st.empty, and we will be checking the same condition, a of st.top. So here st.top is a of 3, so means here 3, and 3 is not 3 is clearly less than equals to 4. So we'll be popping the first element, and again here we'll be checking the same condition, and here we'll be having the 0 value at the p of I. Then again we'll be pushing the value 2 here, st.push of I. Again we'll be moving to the next iteration, and here we'll be checking st.empty, and here st.top. So here st.top will be 4, and it is not less than, so we'll be just pushing the current value, that is a of top. So here 2 will be pushed, and now 3 will be pushed into the stack, and now again checking the same condition, that is a of less than equals to, yes, it is less than means equals to. So here we'll be popping out the result, and now if st.top, so here again we'll be pushing the 2 value, and this will be the value that will be getting the for the p. Once we have done this, similarly doing for the s, in this case that will be doing the same operations for us, but here we will be doing the same operations from the last end, that is from the last, and we'll be checking the similar type of conditions, and here we'll be pushing all the values into the s of vector, that is suffix vector. And once we are done with the prefix and the suffix vector, here we'll be checking, we'll be having the answer vector that we have to return, and we'll be pushing answer of I equals to I minus, that is here suppose, let's suppose the s value for I will be calculating the first value here. So I equals to n minus 1 and I greater than equals to I minus minus. Okay, so in this case we'll be pushing okay, so I will be calculating the last value here. So while a stack is not empty and array of st dot top, so here nothing is pushed, and here the value will be equals to 4, that will be pushed here. Okay, right? Because st dot push will be there, and there is no such operation that will be performed here because the stack is empty. So clearly here we will be pushing the 4, and that's what here we will be getting also. So for this value we will be getting the 4. Okay, so once we have got this, once we will be doing the s operation, that is suffix operation, we'll be getting the for I int is equals to 0 till I less than n, I plus plus, will be performing this operation and it will be giving our result. So uh, suppose for this s value, here we'll be getting the 4 at the end, while when you perform the operations you will get here 4. So let me check the operation, that is answer I. Answer of 0 will be here in this case equals to I minus I is 0 and pi will be minus 1, so plus 1 minus 1. So this will be the case, and the next s of I will be 4, and then 4 minus I will be 0, and here it will be value of 5 I think, and 5 minus 0 minus 1, this will be the at the end also it will be 5 value. So here we will be getting the result 1 minus 1 equals 0 and 5 minus 1 will be equals to 4. So 4 will be the result, and that's what we are getting here. For the first value we are getting the value as 4. So for each index, if you check the conditions, you can get the result. So here the concept is basically we'll be checking for the both the ends, that is that is we'll be checking from the left to right condition, and then we'll be maintaining the prefix array, and for right to left we'll be maintaining the suffix array, and then we'll be having the certain condition, that is I minus, that is we'll be here finding the difference here, and once we have got the difference, we'll be once we have got the difference and we have added both the differences, so here we'll be getting the answer vector. That's what we are returning here. So let me compile this code. Yeah, for compilation it is okay, so let's submit it. Yeah, for submission also it is okay. So that's it for this question also. Okay, let's take the doubts here. Uh, Okay, Pratham, I think there will be a technical issue if you have submitted both the answers. You will definitely get the marks. There might be a technical issue there, so don't worry about that, and keep focusing on the questions. Okay, winner didn't understand the approach here. Okay, here the approach is that we'll be maintaining the prefix array and suffix array from both the ends, and we'll be for maintaining the prefix array and suffix array we'll be having the stack, and for the stack we'll be checking the top of the stack if it is less than or equal to a of I. In that case means if its power is greater or lesser, if its power is lesser, in that case we'll be popping that result, and will be not doing something. If its power is greater, in that case we'll be not popping that result, and we'll be having that on the top of the stack, and we'll be checking for the other ends. So here we have maintained the two arrays, that is the prefix array and suffix array, and those will be giving us the result. So this is the kind of approach that we are following here, and you can do this question using the brute force approach. Can be you have to find for all the indexes, we have to find how many indexes you can remove while decrementing the sizes, while the size means if the adjacent elements are while the adjacent elements are not greater, you will be decrementing the size, and here you will be counting the number of elements that you have decremented. So that can be the brute force approach, but the efficient approach here can be using the stack. And here you have to maintain the two stacks, and here you can make one stack also if you are clearing this stack. If you means if you empty the first stack, you can maintain the second stack also. And here once you have got once you have done this, that is prefix and suffix array, you can just find the differences of both the from the initial and the finding positions, and then you will be pushing that to the answer of I, and once you have calculated the answer of I also, you can return the result. So that's what we are returning here. So I'm done with all three questions. If you have any doubt, you can ask, and then we'll be moving to the MCQs part. Okay. Okay. Uh, There's a technical error also that I faced in the website. Remaining time was showing 6 minutes on 7:30, and my 5 MCQs was remaining. Okay, the time slot for the question contest was from 6 to 7:30, I think. So you have to complete those on time. There's a time bound that we have to complete, and if there is a technical issue, then I think the team will be giving you the updates. And if the contest was okay, in that case you have to be on the, you have to submit all the questions on the time. Pratham Gupta, can you explain the second question in brief? Okay, second question was the reach the end problem, and here we have been given the two scenarios, and here we have, firstly we have been given the buildings, and for each building we have been given the certain height, and if we have to travel from first building to the nth building. Okay, now we are given the two scenarios. If we are moving to the next building, that is adjacent building, in that case we have to spend ax minus ax plus 1 energy, that is the difference of the heights between the two buildings. Okay, that's the difference. And if we are moving, suppose we are leaving the one building in behind between, in that case we'll be have to spend that is the difference of the both buildings height into 2. Okay, and here we are given the question as this. So for this question we'll be finding both the approaches, and we'll be applying both the possibilities. Whichever will be giving the minimum, will be sticking to that approach. So here we have approach, that is we'll be having the from building number 2, means the second building will be having the approach, that is we'll be finding the dp of I equals to minimum of dp of I minus 1. Suppose we have calculated for the I minus 1th building, what will be the minimum energy that we have to spend here for coming to the I minus 1th building. Okay, once we have calculated this, we'll be having the absolute differences, means if we are moving to the adjacent building, in that case we will be having the difference of both the buildings, and we are adding that to the dp of I minus 1 for what we have calculated already. And if we are moving to the, suppose we are leaving one building in between, in that case we will be moving to the I minus 2th building. Here we are moving from the last position. Okay, so here I minus 2th building, and once we have moving to that, we'll be having the difference and into 2, because here that's what we have mentioned here, that is the energy is equal to ax minus ax plus 2 into 2. So that's what we are spending here. We are, and the energy that we have to spend here is absolute difference between the buildings heights and into 2 times. So for if we are leaving one building in between, and if we are leaving no, we are moving to the adjacent building, in that case we have to just add the difference between the two heights. So once we have calculated both the two, so here we will be finding the minimum of both, whichever will be giving the minimum, will be returning that at the end. And once we have calculated for the whole dp, we'll be returning the nth minus 1 index, that will be storing the minimum energy that we have to spend for moving from starting position till the end position. So that's what the second question was about. Now moving to this now moving to the mcqs part. So I will be discussing the computer awareness questions here. So here we are given the first question as that is, we have been given the sample pseudocode, and we have to find whichever the option suits the best. So here we can clearly see that for each operation we are checking the two cases here. Okay, so we'll be checking if x is equals to 0 or 1. If x if means if it is a 0 or 1, then we'll be just returning that x. So if x double equals 0 or x double equals to 1, so we'll be return x. So this is the first condition. Second condition is if x modulus 3 is not equal to 0, in that case we'll be returning 0, return 0. And then we'll be checking we'll be having the recursion call for the same function, that is for x by 3. So it is clearly if suppose we have the value as 9 initially, x equals to 9. Okay, so clearly x is not equal to 0 and x is not equal to 1. So and here we'll be checking if x modulus 3, so 9 modulus 3 not equal to 0. This is not the case. 9 modulus 3 is clearly equal to 0. So here we'll be not getting to this condition. Now we'll be calling the same function, let's suppose s is the function, so for x by 3. So x by 3 is equal to, now x will be becoming 3. Now for x equals to 3 we'll be checking the same condition, that is if x equals to 0, no, it is not the case, and if x equals to 1, it is also not the case. Now we'll be checking the same condition, that is if x modulus 3 not equal to 0. So 3 modulus 3 clearly it is equal to 0, so we will be not moving to this condition also. Now we'll be calling the same function, same recursive call for the x equals to 1, that is x by 3, that is equals to 1. Now x equals to 1 and x equals to 0. So here clearly x equals to 1, so we'll be returning x. So 1 will be returned here. So clearly we are checking, suppose we will be reading the options. So here we can see that if it will return 1 when x is power of 3 and return 0 otherwise. Let's suppose we have considered the x equals to power of 3, that is 3 to the power 2. Let's suppose we are considering here the example as x equals to 6. In that case here initially the x is not equal to 1 and x is not equal to 0, so we'll be not returning anything. Now again we'll be checking x modulus 3 not equal to 0. So here clearly 6 modulus 3 will be equal to 0, so here we'll be again not moving to the next condition. Now we'll be return s of x by 3. Now x will be becoming equals to 2. Okay, 6 by 3 equals to 2. Now x not equal to 0, and here this condition is not okay. Now we'll be moving to this condition, 2 modulus 3 not equal to 0. This is condition fails here, and now we'll be returning 0. So we can clearly see that if it will return 1 when x is power of 3, otherwise it will be returning 0. So this is the case that we have to consider here. So this is the correct option in this case. Now moving to the second question, how many times is a recursive function called and when the following code is executed. So here we are given the following code, and here we have to find how many times the recursive function will execute. So here the execution pass, that is the parameter here we will be passing n equals to 20, n equals to 20 in this case. Okay, and here we are calling the same function by decrementing n minus 1. So clearly there will be 20 calls for while n is equals to 0, and one call for the uh, means a false condition. So clearly 20 plus 1, that is 21 calls will be there for the this function. So that's what we have to return here. So clearly the answer will be 21. Now moving to the next question. Here we are given the number of internal nodes, and L will be the number of leaves in complete an array tree. And here we are given L value and that is number of leaf nodes and the number of internal nodes. So L equals to 31. So here you can check by Dragon here, and you can also check that is if suppose we'll be dividing here L by 31 by 8. Okay, so you will clearly getting the seal value here, that is 31 by 8 will whatever will be the given the seal value, uh, it can be your answer. So 31 by 8 clearly equals to 4. So 4 can be your answer. Let me draw something so that you can understand better. So here we'll be having the root node, and then it will be having its 4 children, right? 1, 2, 3 and 4. And since it is a we have considered it as 4 array tree, so it will be having a 4 children. Then it will be having again 4 children. 1, 2, 3, 4. Then 1, 2, 3 and 4. For this 1, 2, 3 and 4. For this also we'll be having 4 children. 1, 2, 3, 4. So clearly here the number of leaf nodes will be we have how many internal nodes we have encountered. We have encountered 5 internal nodes right now. Okay, now moving to 3 more internal nodes. Here we will be having 4 nodes. Now this will be also the case, and it is also having the 4 children. For this also it is having 4 children. Let's suppose this. So now we have internal nodes, that is I'm highlighting with it as green. So this is internal node, this is internal node, this is internal node, this is internal node. We have 5 internal nodes till this point. Now 6, 7 and 8. Once we have 8 internal nodes, now let's check how many leaf nodes we have. So clearly we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and then 22, 23, 24, 25. Okay, let me again count this. There might be some issue. Okay, so since we are considering an array tree, so here 5 and 4, 5 and 4, 9, 9, 4, 13, 13, 4 will be equals to 13 and 4. It will be 17, 17 and 4. It will be 21, 21 and 4, 25. So here we have to find 31 nodes, and that is the nodes that we have to pass here, and we are given the 8 internal nodes. So this will not be internal node here. I think here we'll be adding 4 more nodes, and that will be giving you the 31 result. So, what does an array mean? What does an array? An array here means how many the maximum nodes the maximum children a node can have. So here suppose we have the an array as uh, suppose 4. So the root node can have 4 children maximum, that is 4, 1, 2, 3 and 4. So that's what we have to find here, and its clear answer is 4. That's what you have to find, and internal nodes are there. So that's here we have to count, and we'll be getting the 31. Have missed somewhere condition, so you can check on your own, and you will be getting the 31, that is more than 31 you can find. So you can check the an array definition as an array tree is equal means it will be having maximum and children's maximum and children. Okay, So this will be the case in an array tree. Now moving to the next question. Here we are given the what is the output of the pseudocode, and here we have given the character array as Biwizard and character array to Biwizard this, and here we are calculating the size of both. So here we have to return the result. So in first case we'll be having the Biwizard, so it will be clearly having the size that is 1 2 3 4 5 6 7 and 8. It will be the size of this given string or the given character array, and one will be the size for the one will be here added more for the null character here. So here null character will be added for the more condition. So here we are getting the size as 9, and since here we are given the character array as differently, so here it will be having the size equals to 8, because we are already having given the result as in the form of character array, and here we are given the character array in the form of string. So string can clearly have the null character at the end. That's what the length increase here. So clearly you have the idea for that. You can check this on the Google, and you can easily get this result, that is you will be having the null character at the end. So because of that you are getting the one more maximum size here. Now moving to the next question. Here you are given the knapsack, and that can carry knapsack. Firstly you need to understand what is knapsack. So knapsack is a kind of a bag. You can suppose that is we are having a bag. Okay, here that can store the maximum weight as 70. Okay, and we are here given the 4 items and value for each, and item will be having a weight. Suppose we are having 4 items. Okay, so this will be having the value and this is weight. So value will be 50 and weight will be 23. Next 15 and 44. Okay, so 80 and 30, and next is 70 and 35. So here firstly we have to find, since we are given the fraction knapsack here, and we have to we can have the distribution here, means one can be fractionalized so that the corresponding value will be added to the result. So here we'll be firstly finding the maximum, that is value by weight value. So clearly this will be having the value by weight maximum 44 by 15. It is clearly around 2.9 something. So this is having the maximum priority here, first number, and then the second priority is having on this value. Third priority is given to this value, that is you can find this by calculating the value by weight, and fourth priority is given to this. So firstly we'll be adding the 15 value here, and the weight we are left, suppose we have taken the item of 15 weight. Okay, and we have added to that bag. So clearly answer, the value will be profit we will be getting here 44, and the left amount that bag can have is 70 minus 15, that will be having remaining weight. Remaining weight is equal to 70 minus 15, it is equal to 55. Now considering the second priority, that is value by weight. So here we'll be adding the 30 weight and we'll be adding the value 80. So 80 will be added here and 30 weight will be subtracted here. Now the new weight will be becoming equal to 25. So that's what we can add now. Now moving to the third value, here we'll be getting the weight here 23, and value for that will be equal to 50. So 50 will be added to the value, and we can decrement the weight by 23. So now the weight remaining weight that the bag can store is only 2. Okay, once we have got this, now 2 weight is left, and we have the size that is 70, and for that value 70, and weight will be 35. So for one weight the value will be equal to 2 in this case. Okay, let's consider this example. So for one weight we'll be having the value 2, and we can add only 2 weight here. So suppose 2 kg here, if we consider the units, suppose we can add 2 kgs, and for 1 kg the value is 2 rupees. So for 2 kgs we can have the value as 4. So that's what the maximum weight, and here the weight the backend now store is 0, and the value that we are getting here is 178. So that will be our answer in this case. We'll be getting the value as 178. You can find this using the knapsack problem also. You can code this using the knapsack, and you'll be if you pass these as a parameter or the values, you can easily get the result. So for that you need to learn how to code fractional knapsack, and once you get that is we can code that using the priority assigning the priorities, that is value by weight, whichever will be the maximum we'll be assigning it the first priority, and then so on. So the least priority will be assigned to the least value by weight value. So that will be the case here. And now moving to the next question here. Here we are given the in order and the post order of the binary tree. Here we have to find the in order and post order of the binary tree if we are given the pre-order. So here we can think of the problem as suppose reverse of that. Suppose we are given the in order and post order traversal. So here we have to find the pre-order traversal, and here we'll be having the dry run for each, that is hidden and trial for each option, and whichever will be giving the pre-order traversal as this mentioned here, that will be our result. So for each in order and post order traversal we'll be getting the result. So let's suppose we are given the binary tree as 1 2. Let me show you the better approach here. 1 2 3 and 4. So clearly it's order will be pre-order. Let's compute, we have to find the pre-order. Okay, so let's compute the its in order and the post order traversal. So in order will be equals to, firstly we need to understand in order. In order is uh, left, root and right. Okay, so here we are having the left, root and right. So for this the in order will be left 4, then root so 2, and then here we are having the root as 1, then 3. So this will be our in order, and let's suppose we are calculating the post order also. So post order will be left, sorry, okay, left, then right, then root. Okay, here the in post order traversal the root will be at end, because post means at the end. So here we are concerned only with the root value. In means in between, and post means at the end, and in case of pre-order the root will be at the starting. So this is the naming convention here. So now we'll be having the left, then right, then root. So 4 will be here. So here is it is not having the right, so clearly the 2 will be there. Now the right subtree, that is 3, and then root, so here 1. So we have the in order and the post order traversal for this given binary tree. Now we have to find the pre-order traversal from this these given orders. So clearly we know that the post order will be having the root at the end, so clearly 1 will be our root. Okay, once we have suppose now, let's delete this tree and make this from the given pre-order and the post order traversal. So clearly we have the idea that is root will be at end, so we'll be having the root, then we'll be finding the value position of the root in that given tree, and it will be the left values will be having the left subtree, and the right values will be having the right subtree. So clearly 4 and 2 will be at left and 3 will be at right. Now again checking in the same, that is 3 will be here and at the end, and now 2 will be at the bit before the 4 in the given post order. So 2 will be at this position, and now 4 will be at the left position, because here we are having the 4 at the left position bit of 2. So that's what we are, once we have found the tree, binary tree, we can easily find the pre-order traversal, that is root, then left, and then right. So clearly the pre-order traversal is this. So for this you can find the pre-order traversal as 1 will be there, then 2 will be there, then left 4, and then 3. So clearly the pre-order traversal for this will be 1243. Similarly, you can apply the logic here. That is, if you are given the in order and post order, you can find the binary tree, and then from that binary tree you can find the pre-order traversal. And once the pre-order traversal matches, that will be your answer. So here we are given the next question as we are given the insert given the certain array, and we have to find the using that insertion sort. So you can do this on your own, and here you have to simply apply the logic, that is insertion sort, and you have to find the number of passes and uh, the number of passes and all comparisons and the swaps, and you can easily result that. Now moving to the next question, find the DFS of the below undirected graph from the vertex E. So here we are given the starting index, and here we have to find the DFS. So DFS is clearly the depth first search. We'll moving to the depth. So here we are starting position is E clearly. So E, we can from E we can go to A, B, or G, that is connected ones. So let's suppose the given example is EBA. So let's validate the given examples. So here E, then B can be okay, and then from B we can move to A, that will be also okay. Then from A we'll be moving to F, that is also okay, and from F we can move to H, that is also okay, and then moving to G. So clearly the first example is okay, because here we are moving to the depth, and it is okay for in that case. Now considering the second example here, from E we can move to G, then to H, then to B, and then A, then F. So it is also a valid example here. Now considering the third example here, now E, A, and then G. So here clearly there is a gap, means there is no connected edge between A and G, so we can't move like this manner. Now considering the last example, E, F. So since the E and F are not directly connected, so we can't have that approach also. So the first two examples are valid, and in that case we have to return only first and second. Those are the DFS representation of the given graph. So now moving to the next question here, what is the output of the following code? So here we are given the integer n value equals to 10, and we are given a class, then we are given a class n, then we are given two variables, that is private variable n and public variable m. Okay, once we are given this, we have been given the constructor initializing both the values, and we can see that here is a semicolon in between. Okay, and if we consider this as inline, that will be a wrong logic here. Okay, we can have that, and then we have the display function in that, and okay. So here that's the logic here is we are missing one bracket here, that is for the display function we are missing the one bracket here, and so we'll be getting the compile time here error here. So now moving to the next question, find the output of the following pseudocode. So let me correct that. Oh, okay, we are given the pseudocode here, that is we have initially c equals to 20, d equals to 15, and okay, let me write the given values. C equals to 20 initially, d equals to 15. Now d equals to c minus 1, so d equals to 19 here. Okay, now we'll be printing c will be printed, so 20 will be clearly printed here. Now if we are checking, then we'll be having the c equals to d plus c minus 2, so d is 19 and c minus 2 is equals to 18, so c is equals to clearly 37 here. And we'll be checking if c is less than 55, go to line. So line is here, here it is a jump statement that we have to move to this line. We can, for jumping statement, we can move use the go to statement. So again moving to this line, now c will be equal to d plus d is 19 and c minus 2, so c is 37 minus 2, that is 35. Now we are printing this also in that case, so 37 will be printed and c is now becoming 54, and again we have the 54 is less than 55, so again we'll be moving to the same condition. and here we'll be printing the 54 value, and now C will be becoming C equals to d minus 2, C plus 19 plus 54 minus 2, that is 52. Now it is clearly visible that is 52 plus 19 is clearly greater than 55. So here we will be having the end if condition, and we'll be out getting out of this conditions. So the values that we have printed here is 20, 37 and 54. So this is a clear representation that we are getting here. So yeah, that's it. I'm done with the post contest analysis of this Biwizard contest, and it was a very good contest, and we are expecting that type of questions, and the questions were of easy to medium level. You can if you have practice, you can easily do that, and still if you have any doubt, you can ask in the comment section, and have the active participation in the next contest, that is Biwizard contest 7. You can check those details. It will be might be on the uh, 26th of September, so you can check that, and you will be updated about that, and have the active participation in that, and still if you have any doubt, you can ask in the comment section, and I'm done with the analysis. Thank you.